Okay, so we want to learn something about a population. We want to know what's the average income of some group, what's the average height of some group, what are people's opinions on some issue, whatever it is. And we're going to learn about that by drawing a random sample from the population, a simple random sample, and figuring out what's true for the sample and trying to extrapolate from the sample to the group. Now, our ability to do that and to understand the size of the error we're likely to commit by extrapolating from the sample to the population is going to depend on how the sample is drawn, and it's going to depend on what we do with it. For a probability sample, you can generally quantify the likely size of the error in extrapolating from the sample to the population. For a non-probability sample, all bets are off. You cannot typically quantify the size of the error that you're going to commit if you try to base an estimate for the population on something computed from the sample. All right, things that you compute from the sample are generally called statistics. We talked about this once upon a time. The difference between a parameter and a statistic. A parameter is a property of the population. A statistic is something you compute from data, something you compute from a sample. There's a particular, if the statistic is being used to estimate something about the population, it's called an estimator. So an estimator is basically a rule for assigning numbers to samples. And so an example of an estimator is the sample mean. The sample mean assigns a number to a sample. It takes the average of the values of the units that you get in the sample. That's the number it assigns. What's it used for? Why is it called an estimator? Well, it's used to estimate the population mean. Okay, so we've got some population of items. Okay, this has some true population mean. We're going to draw, say, a simple random sample of size n from this population that has capital N items. From that, we could compute the sample mean. And the sample mean would be an estimate of the mean of what's in the box, the population mean. But it's not going to be a perfect estimate because the value of the sample mean isn't always the population mean. In fact, typically it isn't the population mean. What value you get for the sample mean depends on which random sample you happen to get. The value for the population mean is always the same, right? It's just some number. So how can we figure out how far off the sample mean is likely to be as an estimate of the population mean? We're going to talk a little bit in general about how do you grade estimators? How do you tell whether one is better than another or not? How do you score them? And then specialize that to looking at the sample mean and the sample percentage, which are the most commonly used estimators.